In this scenario, we will show how successful products can be built by means of the Mecodes tool for ECAD-MCAD collaboration. In typical collaboration, data is exchanged between CAD designers during the design process, where they exchange models to improve their designs. The scenario starts with the ECAD designer, where he develops a schematic for the PCB design. We see the creation of a PCB schematic for small PCB called the indicator. After the initial design is ready, the ECAD designer starts the ECAD-MCAD collaboration by giving the request to the MCAD designer to create a new PCB outline. This is done through the messenger client, which is an integral part of the Mecodes collaboration environment. The MCAD designer logs to the Mecodes system, and their messenger client automatically starts showing them the latest request from the ECAD designer. Since the major mechanical components and geometrically important electrical components may influence this design, he puts mounting holes and an electrical connector to the board outline. In this way, he makes the ECAD designer aware of important geometrical restrictions, which must be known to make a successful design of PCB. After finishing the placement of components, he exports the design to the Mecodes system and informs the ECAD designer that the initial PCB outline is ready. This initial PCB outline represents the baseline in Edmd protocol terms. The ECAD designer starts the Edmd Collaborator tool from the Expedition menu and imports a newly designed PCB outline. We see that this layout, after it's been validated, fits well to his design, and he can put other components to the board. In the step called back annotation, he puts all other components to the board. When all components are placed on the board, he informs the MCAD designer that new changes are ready and are exported to the Mecodes system. Immediately after the message pop-ups on the MCAD designer's desktop, the latter can start importing a new design change into his current design. During this processing, he has the opportunity to selectively check the effects of each change proposed by the ECAD designer. This is done through the Mecodes process called the Change Request Management, which is integrated in the CATIA V5 workspace. After the changes are accepted and applied to current design, the MCAD designer confirms the change transaction and sends a response to the ECAD designer. By this step, the ECAD designer is informed and is aware of all changes which are accepted or rejected by the MCAD designer. This is necessary since in this way both collaborating parties end with synchronized designs. Now, the MCAD designer may play with the design actions, for example, move components, change top-bottom component position, define placement and route keep-out areas, or even change the packaging of the component, as well as many other design actions. For instance, he may define two keep-out areas, one for the routes and the other for placement of small components. We will see how these areas are recognized by the MG Expedition and how they restrict the ECAD design there. After some component rearrangements, the MCAD designer sends a new design change request. The ECAD designer accepts some of actions from the change request and rejects others, indicating that he is not satisfied with certain design changes. After a few checks of approved changes, he improves his design and sends a response indicating what was accepted and what was rejected. We see that these keep-out areas are effective elements in MG Expedition and put effective restrictions on ECAD design. The ECAD designer improves his design and sends a new change request to the MCAD designer, indicating that the PCB design has slightly changed. The MCAD designer receives a new change request and accepts all actions from it. With the aid of the Mecodes system, he can see the history of all collaboration steps from their very beginning. Here we see the steps with full information regarding actions performed when the baseline or change requests are processed. What is very important is that the MCAD designer retrieves any of these steps and reapplies a request to see what happens to his design. With this functionality, he can play with the what-if analysis during the design, which is very important for the quality of design and for the overall collaboration process. Meanwhile, the bottom board designer decides to change the position of one component and sends that request to the MCAD designer. The MCAD designer detects that this change request will be in conflict with the upper board and decides to change the upper board outline and root replacement outline. After he makes changes, he sends the change request to the upper board designer with the changed board outline and changed root outline. The upper board designer validates this request and approves it completely. Now the MCAD designer can approve the request from the ECAD bottom board designer, indicating that movements of these components are now acceptable and verified and can be performed. Now both ECAD designers finish their designs and send a final design with all elements of the boards: outline, components, roots, holes, masks, screens, etc. Being finally satisfied with the design, the MCAD designer requests the ECAD designer to finalize the PCB design and to add all other information such as roots, masks, silk screens and others. The ECAD designer initializes the routing process on his board. When it is done, he exports all the data through the ODB++ format. The MCAD designer imports ODB++ data with all information and puts them in the case where both boards reside. Being satisfied with the designs, he informs the top and bottom board designers that the boards fit well to the case. Now he has information enough to continue with advanced checks such as temperature simulations, EMC checks and others. After the successful design collaboration, the product is ready to take further steps in the product making process. This all has been done by means of the Mecodes system. One important part of the Mecodes system is common library management, which is used to establish collaborative components. With this part of the Mecodes system, designers prepare components which are available in native formats for both tools, ECAD and MCAD. The collaborative components are created by linking CATIA 3D representation with the footprint representation. The isometric transformations are used to align CATIA 3D representation of the component with the footprint representation from the ECAD tool. Components created in such a way allow designers to exchange useful information between CAD domains.